Hello, I'm MC Toon, and it's Tuesday night. Today is Tuesday, and that means I have a debate. This debate is with Watsupp, a guy on Ranty Flat Earth or Flerfspective's Discord server who called me out. So we set up a debate. He said he had only half an hour. I said, that works for me. I only have an hour. But it took a little longer. So yes, that means this is pre-recorded. I am not at home tonight, so I thought I'd bring you this as it just worked out coincidentally. So sit back and enjoy the amount of evidence that Watsupp brings. I mean, the not amount of... Well, anyway, you'll see.
What's up? Do you want to introduce yourself?
Well, yeah, sure. So a lot of you might have heard about me, but most of you don't ever talk to me, by the way. My name is Watsupp, and I've been around for like 4 or 5 months and tried to look for constructive and productive conversations regarding the flat Earth and globe Earth topic.
Okay, wonderful. And MC Toon, do you want to introduce yourself as well?
Yes, I've been... Next month marks 3 years of YouTube videos for me on the topic of flat Earth, and I also cover other things like 5G and other kind of scammers in general, people that make up stuff to get money out of people, intentionally or not.
Okay, right. I'm going to pop you on mute for a little bit there, Peck. 1 sec. There we go. Right. So I'm just moving. I'm just trying to organize things on my laptop too. So in case you guys want to share anything, so I can share it with the audience so that everybody can see. Does anybody have a preference with who's going first?
I don't. What's up? You want to go first or second?
I think I should go second, by the way.
Second. Okay. Excellent. Yeah. Well, I'll just jump right into it since you had said you had kind of a limited time. I have an hour. You said you had half an hour, so somewhere between a half an hour and an hour.
Half an hour, yeah.
Yeah, we'll have to end it. So, we talked about specifically the shape of water. You had mentioned that you think water is flat, and that you didn't like the term flat earther. But I said, well, if water's flat, then that makes the entirety of the earth flat because the surface of it is primarily water. So if I use the term flat earther, that's why. So the thing is, though, that we can measure the surface of water to see if it is flat or not. And it has been measured. And I can give you I have 2 particular measurements that I like to refer to. So I'll share my screen so that you can see what it is that I'm doing here. Let's see.
Okay.
So there you go. You should be able to see what I'm sending right now. This is from let me pop up to the top, a licensed geodetic surveyor whose job is to survey things.
I've heard about him, yeah.
Yeah, his job is to survey things. He needs to know how to use the equipment that he's using. So he set up on a lake that was calm, on a calm day, and the lake is kind of isolated. It's surrounded by trees and stuff so that it doesn't have a large amount of roughness to the water. You can see in this picture here how smooth it is. So if the surface of the water is flat, then if you have 2 things set up opposite each other at the same height, they will measure to the same height. And if it's curved, then they will measure to different heights, either up or down, depending on which way it is curved. So here's a little bit of his methodology. I will put into the chat. I'll do this quick here so that people can look on their own. There it is.
Okay, I'm sorry, just a little cut in. Is this your proposition, which only a statement, and then we dwell into, or are you already showing and trying to explain the sort of experiments that you talked about bringing here?
Yeah, this is the measurement of the surface of water.
So this is already one example of the proposition that we agreed on. Okay, because I just want to jump in and quickly say that my proposition regarding this whole question is that there has never been a real measurement regarding the radius of the Earth or the curving of the mean sea level.
Okay, well, before we get to that, could we just let McToon finish what he has to say with his presentation, and then you can argue it afterwards?
Yeah, the presentation comes in the second part, but yeah, that's why I jumped in.
Okay. Do you want to carry on, MC2?
Sure. Well, I mean, it goes right to it. If you say there hasn't ever been a measurement of the surface of water being curved, then you may not be aware of this, but that's what this is. This is a measurement of the surface of water. So here we have a target. You can see it's got these lines on it. That's the target that they use. And then up that taller thing is a GNSS, actually, location instrument. Here he's measuring the height of his instruments. He does it on both sides. He uses a theodolite there. This is a non-electronic theodolite. It's an older one. So no claims of NASA electronics can be in it. So he goes over his methodology. I'm not going to go over too much of it, but we can see here through the crosshairs of one, at the other side there, that target that it's on is the GPS location thing. It's not the actual target that's at the same height as the theodolite that he's using. That's below the line there. So there's a drop from horizontal across the lake. So lots of pictures here, but the important thing is that he measured the drop, the angular drop, used the distance across the lake to get the not just the angular drop, but also the drop in linear units. And because he's an American, he uses freedom units, so it's in feet instead of centimeters. I would prefer centimeters and meters, but over 0.48 miles, there's a drop of 0.15 feet. Right, so that's just under half a mile and a drop of 0.15 feet. He did the same thing at 1.38 miles, and I'll put this particular measurement also in the chat. There it is. At 1.38 miles, a drop of 1.28 feet. There's the little diagram of it. So there is measurement of the surface of water being curved. If it were flat, then they would line up. And if it was curved down, like on the outside of a sphere, then the other target would be lower than the crosshairs. That's my presentation.
Okay, and can I just say for the audience that's watching, I do believe that MC2 and you're going to be releasing this with footage yourself that you've taken yourself. Is that right? Later on your channel? Yeah, I'm recording this. I'll put it on my channel later. Hopefully today. Wonderful. Okay, it's just because on the laptop here, it's it's having a little bit of a fit to try and watch your stream. So if anybody wants to actually watch what you presented there, then it will be on your stream, on your channel later. Okay, right. But did you follow everything that MC Toon said there? What's up? Yeah, sure. Was there anything that you? Was there anything? Was there anything that you were unhappy with about his presentation? Not about. Yeah, sure. I meant was there anything that you didn't understand? That's what I'm asking to clarify things. Okay. I understood everything perfectly. Thank you. No worries. Okay. So would you two like to get into a debate about that right now? Would you like some questions? What's up? Well, the format was we both were going to bring our measurements, so that was mine, and so Watsupp gets he should have a chance now to present his measurements. Okay, right, wonderful. Okay, Watsupp, would you like to share your screen then? No, certainly do not want to share my screen in the first place, and in the second, I have not brought any kind of presentation. So if you had the idea that I will, I'm sorry, I will not. But again, in a debate, very first step is that you claim something.
You present your viewpoint regarding the same topic that both parties agreed upon. That's why I jumped in, because Macton was going into the actual presentation of why he has this certain side of a certain topic, right? Right now, the topic is the radius of the Earth. That's what he told me in the end. Right now, it was the supposed measurements of water curving over a long distance. I have certain questions about that presentation, by the way, but that's not going to be a debate then. So I get no problem with dwelling into that kind of conversation at all. Let's do that, because Renty is here, the boss, so I'm going to go with that. My first question regarding those kind of measurements that Jesse has done. Did I see it right that one of the distance in between the theodolite and the measured object was almost 0.5 miles away, and that's the right. Other one was 1.38 miles, right?
That's right.
Okay, so one is about 800 meters, and the second is about 1,200, maybe 300, around that. He used a theodolite, right?
Yeah.
Now, he used it to measure some kind of angle deviation from the horizontal plane that he supposedly had with the theodolite. Now, in my understanding, surveying, you usually want to use an auto level. Nowadays, they use a total station that could do any kind of angle measurement, auto level stuff, and probably way more. What I heard in this community is basically that the auto level will establish any kind of surface, on any kind of ground. If you set it up correctly, it will establish a horizontal plane. Now, as I know, there is a working range for any kind of auto level, and it is within the distances of 50 and 80 meters. My question is, why would anybody use a theodolite for around a mile and half a mile distance to measure an angle deviation from the horizontal plane that is supposedly sets up?
Okay, that's a great question. So theodolites do not have a maximum working distance. The total station that some people fraudulently claim has a maximum working distance is strictly about the laser range finding. I have on my website the actual documentation linked, mctoon.net/Theo, THEO, where you can see in the manual that it does talk about the distance limitations of the laser rangefinder. There is no actual distance limitation for a theodolite to measure angles, and that's what a theodolite does. Now, why would you use a theodolite instead of an auto level? Well, a theodolite is significantly more accurate and precise than an auto level. It does establish a horizontal plane at a point when you turn it to 90 degrees zenith. That's what it's for. And like I said, it's significantly more accurate. The one that Jesse Kozlowski used is accurate to 1 arc second. So that's 1/3600th of a degree. That's its stated accuracy. It doesn't have any distance accuracy limitations associated to that.
The theodolite, yeah, you're right about that. But you mentioned that it's very accurate for what?
Measuring angles. That's what it does.
Exactly. Yeah.
And like I said,
angles in between
the one that Jesse used did not include. It is not a total station. It is not a. It doesn't have a laser range.
It's a theodolite. It's an old theodolite without the fancy stuff that you can get with the one that you could get today.
Yeah,
I get it. Yeah, certainly, no problem there. So my question is, how did he establish first and foremost the horizontal plane?
He turned it to 90 degrees zenith.
Well, how can we know about that?
That's how you do that. What's that?
Yeah, I get that. I get that you can do that with the theodolite. I get that, no problem. But how is it documented in the first place?
How is it documented? What would you expect for documentation from a licensed geodetic surveyor?
But I just want to interrupt and ask this question. Why is that? Why do you think that's important? I mean, you're asking somebody to answer a question that probably he has no way of actually answering because I'm going to put words in your mouth here, but he wasn't there at the time and somebody else did it. So you're asking him to try and make things up. I don't get it. Could you stick to the actual presentation?
Yeah, I'm staying towards the actual presentation. I'm just, he brought it up, right? I didn't.
Yeah, so
I can ask about it. Can I not ask about it?
Well, you've asked about it, but I don't see that there's any relevance in the response. I don't see in any way, shape, or form how that's going to address the actual presentation that was put forth. I mean, unless you can clarify it for me.
How was the horizontal plane actually established? That's what I asked, nothing else.
No, I think you said documented.
Yeah, you said documented.
And how was it documented?
Yeah, I think documented is completely different. I don't think it's relevant how it was documented. But carry on. I mean, Matsuna, if you want to try and if you want to answer that, fine. But I don't see it being, a valuable point.
The documentation is on the webpage. He said he turned it to 90 degrees. That's it. So if you're going to suggest that you can't accept that because you didn't see photographic evidence of it measuring at that particular angle, then that's just incredulity. And if you think that that's not accurate, then feel free to provide evidence to the contrary, but lacking evidence to the contrary, incredulity doesn't do anything. Okay?
Yeah, sure. It was just a simple question. Don't be upset about it, please.
Can we move on then?
So let's move on. Yeah. The basic problem, in my opinion, is the question as to why every auto level has a certain working range, which is way within 100 meters.
I didn't present anything with an auto level, so I don't know why it's completely irrelevant to this conversation.
Bringing up the idea that there must be something over at 100-meter distance in between the optics that you are using and the object you are looking at. Because no auto level has a working range of 200 meters, let alone 800 or 1.3 kilometers. I'm talking in meters and metric system, by the way.
Yeah, I definitely prefer metric.
Yeah.
Or sheet
there
units.
Is something
if
that's happening. Yeah.
Can I just ask,
I will stick with the metric.
Is it for ground? We're talking about ground surveying here, the working distance that you're talking about.
Yeah.
So we're talking about ground surveying. Okay, so theoretically, what's happening here is that you're trying to use a tool or suggest that a tool that was never designed to be accurate from more than a certain distance because of Earth curvature, bearing in mind, is going to be, you're asking why that isn't suitable for the job that you want it to be accurate to a mile. In other words, you want to be able to establish that you can see an 8-inch drop or thereabouts. But that isn't reality. I mean, the auto level was designed to be level up to a certain distance, and after a certain distance, it becomes not usable simply because of the Earth curvature that takes effect past that distance. There's a margin for error at a certain distance. So I know that I'm sort of speaking on behalf here of Mitsune, but I would have thought that this was, you're coming into a debate about why auto levels don't have this range, when I think it should be pretty standard for you to understand why it doesn't have a range that's accurate at a mile. That should be pretty obvious. It's in the manual.
First of all, I didn't know I was debating the two of you.
Sorry, you're right. You are right.
Going to be two moderators.
That's true. I'll tell you what I'll do. Amy. Sorry, you're absolutely right. I'm too invested in this right now. So what I'm going to do is I'm going to step away, and I'm going to let Amy be the second moderator. I was afraid this might happen, so I'm going to pop myself on mute now for the rest of this debate, and I'm going to let Amy take over as the moderator. Okay. Sorry, guys.
Okay.
Thank you.
No problem. So what I wanted to say, basically, before Rentby jumped in, is that you only have a deviation over a distance, in which distance we are talking about the theodolite having a distance towards a object it's looking at, about 800 meters. Now, we know exactly that kind of observation through a theodolite to come up with any kind of measurement is inaccurate.
Why?
By at least 8 times, or on the other hand, 13 times. Because
can you send the citation for this, please?
The working range for the auto level. That's why I brought it up. Yeah, I know. Again, auto level.
Okay, I'm not talking. Sorry, theodolite. I will not talk about auto
I know
level.
That.
That is not the topic. Unless you're bringing that up as evidence for something, you are trying to address my theodolite-based measurements by talking about auto levels. I don't care. Don't talk about it again.
Okay. Don't talk about it again. But
I don't, because I don't care. It's not what I brought up.
In a debate, you cannot say what the other party can or cannot.
Okay, tell you what. Okay, admit defeat by bringing up something off topic. Thank you. There you go.
Off topic. No, I was trying to connect the two before you jumped in.
Okay. So again, well, go ahead. Address the evidence I brought.
Trying to do that for the third time right now is that in any kind of optics, including the theodolite, there is gonna be an inaccuracy regarding what you are trying to do. Now, in this case, you are trying, not you, Jesse is trying to come up with a horizontal plane and then try to measure a deviation from that plane regarding an object that is 801, around 1.3 kilometers away. 800 meters and 1.3 kilometers away. Now, the problem is that it's not just that. We are talking about angles, of course, but how do you know that it's not regarding and because of some kind of a refraction that is happening all the time whenever we are looking to a distant object?
How do we know it's not refraction? Well, of course, refraction is absolutely always happening when you are going through a medium. The effects of refraction through the atmosphere are known and have been measured. And we do know for certain that under the regular conditions, like is happening here, refraction causes distant objects to appear slightly higher. So if you want to talk about refraction, it won't help your case, but I'm glad to talk about it because it will incorrectly measure slightly higher than it actually is. So if we do take into account refraction, then we know that the drop is more than 0.15 feet at 0.48 miles. But certainly if you have evidence to the contrary, again, I would love to see refraction evidence to the contrary. Of course, as always, I do have evidence supporting refraction on my website at mc2.net/refraction that does show many different studies with empirical measurements of distant objects appearing slightly higher under the effects of refraction.
I'm sorry, I didn't know that this is going to be a PR for your website because you mentioned it 3 times already within 10 minutes, but I don't have a website. I'm just here to talk to you.
I'm doing it to cite evidence.
What I would like to talk about more is that when you admit that there is a refraction. Now, we have to talk about this because this is very simple, but it seems, I feel like we have to, that when you are looking at a distant object, especially in any kind of place where you have the atmosphere, which is basically, in other words, simpler words, the air, then you will have refraction always. You cannot rule it out. You cannot force it out. You cannot, just forget about it. It's gonna be there always. Now that means, and especially after you admitted that, there is refraction, is that you are actually measuring an apparent thing.
Absolutely.
Now, how would you,
everything would anybody, is apparent,
why would you measure an apparent thing in the first place? And in the second, why would you account it as a geometrical result for anything?
So, excellent question. And scientists do know how to account for conflating variables. Since the effects of refraction have been previously quantified, you can use those previously quantified effects of refraction to adjust the results of your measurement. Like I said, if we want to, we can in this particular example, but it does not help your case because the effects of refraction would cause these distant objects to appear slightly higher, thus making the drop in reality even more than 0.15 feet. So,
okay, I'm sorry. I phrased it in a way that it sounded like a question. I do not want this conversation to become me asking you and you always answering. I wanted to finish with, in my opinion, because we are, I mean, not we, because I would never do that, but Jesse and anybody who agrees with what he did is actually measuring an apparent thing, which you should never do. I never heard about using a ruler or a tape measure for measuring a car that is in the distance. Like, that's nonsense to me.
Well, when you look at a tape measure, the light between the tape measure and your eye is refracted. So you're only looking at the apparent tape measure. So please explain how you could measure anything at all ever.
We are reading
that isn't
a tape measure. We are reading off a tape measure when we are measuring the physical object. We put the tape measure through at the object, and we are looking at what does it tell, where is the end of the edge of something on the tape measure. It doesn't matter how light refracts into my eye.
Okay, so it seems like you misunderstand what's called margin of error in measurements. All measurements have a margin of error, all of them, including a tape measure. If your tape measure has gradations at every 1 millimeter, the margin of error is plus or minus 1 millimeter. If you're measuring something on a cold day that's long with the tape measure versus measuring the very same thing on a long day with a tape measure, the length of the tape measure will in fact change. It increases the margin of error, but it doesn't make the measurement invalid. So unless you can show a measurement technique that has zero margin of error, then it doesn't matter. What you do is you account for those errors and you record them and it is in Jesse's measurements. He does have a margin of error analysis.
I tell you what,
standard
if it
deviation
affects the tape measure, then it affects the object too, which means that it's gonna be the same measurement. But
no, everything has a different coefficient of expansion for heat. Okay. So unless the tape measure and the object you're measuring are made of the same material, they're going to expand and contract at different rates.
Okay, so let's go to the next step, which should be, again, I'm sticking to this. You are measuring, and not you, but Jesse is measuring an apparent thing. I would never do that in my whole life because I cannot come up with a real result regarding geometry.
Okay, so how would you measure something with zero margin of error?
No, not margin of error. Again, I'm talking about apparent things, measuring apparent things.
All that does is it contributes to the margin of error. That's how it works. So you are denying that you can measure anything then, is what you're doing.
No.
Well, how do you measure things without a margin of error? How is it done? How do you measure things with zero margin of error? That's what you're demanding.
We dwelled into I won't let you talk from your part. So the second thing that I wanted to say before you jumped in like 3 times within the past 30 seconds is that how do you know that light refracts in a way that it's going down from the actual geometric shape that it should have?
Because it's been empirically measured for centuries.
That it's only going down, nowhere else.
Yeah, it's been empirically measured for centuries. And I gave a citation to several different sources that have measured that. You can, if you really want, you can look at the works of Gauss. I don't read German, so I can't look at that, but he has a huge number way back a couple centuries ago of measurements of refraction effects over long distances. So this is known. It's well documented. People don't actually, that I've seen, deny that light bends down through the atmosphere. This is, I guess, strictly you that thinks that. But like I said, I have citations on my website if you want to look at them and find out to see what the actual empirical measurements say.
So I'm sorry, but if you look into the refraction itself and what does it do, then you will find that refraction happens in between 2 distant and distinctive layers of medium. When we are talking about light, of course. Now, that deviation that is happening at the edge of the both of the layers could be anything, literally. I do not know. Why would anybody say that refraction always happens towards one direction, which is right now the gravitational forces direction, by the way? Down, right?
Why would they say that? Because
Vertical
it's been
down.
measured. Like I said, it's been measured.
No, what's really been measured in other experiments is that light always and will deviate in certain ways. Like it's all regarding what is actually going on, of course, every and each time. But that kind of blatant claim that light always will bend downwards when you are looking at an object that is distant from you, like kilometers away. But then having lab experiments in which they can show you that no, light can deviate to any kind of direction regarding what's the two medium, what is the... Oh my, okay.
I mean, you're making a claim in without
this case,
evidence.
You're right, I should bring something I didn't, so you're right about that, because this wasn't the original topic, but never mind.
It sounds like what you're doing is you're trying to just cast aspersions on the field of surveying that has been using these particular types of measurements for centuries, and the people paying them have not been complaining about it. It's a very successful field using very successful methods, and you're claiming that they're invalid with no evidence to support your claims.
No, I'm not claiming that at all. What I'm claiming is what I claimed the first time I spoke, is that I would be very surprised if any surveyor would tell you that they use their equipment over 800 miles for actual measurements.
800 miles?
Not this kind of thing.
No, they don't use it over 800 miles.
Sorry, 800 meters. Yeah, you're right. Yeah.
Well,
so
they do it all the time. In fact, I can cite many geodetics or just surveyors measuring things over many miles, not just 800 meters. Like I said, the auto level is not what they're using. They're using a theodolite. It's a different tool. And they do things to deal with the necessary margins of error and conflating variables that happen.
Conflating variable. What do you mean by conflating variables?
Well, conflating variable.
That's what you're referring to.
Conflating variable would be anything that adjusts or affects your measurement. So yes, refraction is one. The temperature of the object is another, because internal things can be a problem. The actual margin of error of the instrument. Every instrument has a margin of error. Like I said, if your tape measure has a margin has gradations at every 1 millimeter, your margin of error is at least 0.5 millimeter. All of those things are conflating variables, and a good measurement will include analysis of all of those things.
Well, as I've heard, for example, auto levels have an accuracy within the range of like 60 meters, 1 millimeter.
Yep.
That's the accuracy that auto levels have.
Exactly. Yep.
Now,
so you've identified and agreed that instruments have margins of error and limitations.
But you're, again, what I also wanted to say is that you're actually using the theodolite, not you, Jesse, is using the theodolite in the same way as an auto level is usually used, because that's what it is, right? He turned an arbitrary horizontal plane.
He turned an angle. Something an auto level cannot measure an angle. It just establishes a horizontal. A theodolite can actually turn the telescope down and give you a reading of the angular measurement that it's churning.
So it has some, again, an apparent measurement. You always have to add that, because if you want to be precise, then you have to be precise.
Yes. And so as we know, the drop that is measured is too small. In fact, we know that the drop is larger than was measured.
Yeah, what kind of error you're talking about?
What kind of error? It's due to refraction.
Yeah, that was never measured there when he did that.
No, of course not at that particular spot. So if you're gonna say that since he didn't measure refraction at that spot, therefore it's invalid, I do appreciate your standard of evidence that demands obviously refraction be included, and the quantification of refraction for all observations. I do appreciate that is your standard of evidence, but that is not my standard of evidence. My standard of evidence is to say we can look at the environmental conditions. We can include previously measured effects of similar environmental conditions, and that adds to the margin of error.
First of all, I do not know what you mean by similar conditions, because every time you would go out, there would be a different pressure and temperature. And as far as I know, those are two things that are needed for actually measuring refraction.
Yeah, the largest,
so if you go
the
out
largest
in the
thing
morning,
is the vertical temperature
midday
gradient.
Or evening.
Yeah, the vertical temperature gradient is the
value
largest contributing factor
for
to that.
your refraction.
No over-talking, guys, okay?
Yeah.
So, all right. So do you have any, and I've provided evidence. You said that you had some. Do you have it yet?
No, that's what I stated at the very first part, didn't I?
That you don't have any evidence.
That I had. No. I said that regarding, what did we agree upon? Do you remember? What's the topic going to be?
The topic was going to be that you were going to have some measurements of flatness, as far as I remember.
Measurement of sea level being flat. Mean sea level being flat, yeah. That was the original topic.
Yes. So
what you wrote had nothing to do with the mean sea level. I let it slide and I dwelled into this. I could have said, man, I'm not going to do this because that's not what we agreed upon. But I dwelled into it because I have no problem regarding that. You wanted to be another topic, at least a slightly different topic. You wrote it, you presented Jesse's presentation that he put up on the website. No problem. You said your website 3 times, which is PR. No problem. But if I did not have in mind this kind of topic, then why are you asking me for any kind of proof of evidence or evidence at all? Please don't do that. Let's move on.
All right. I have been monopolizing this. I apologize. I will let you present your evidence.
Again, this wasn't the topic that we agreed upon. Do you get that?
Whatever topic you thought we agreed upon. Go ahead. Present your evidence for that topic.
No, we are not doing that. What we're going to do is talk about the same subject that we've been talking about. Okay. So the basic thing that I did say, my basic claim is that you cannot measure things. And my follow-up to that, after you had the presentation regarding Jesse's experiment, or observation more like, I said that he is measuring an apparent thing in the first place, and then coming up with a geometrical result for it, a physical result for it. That's nonsense in my book.
Okay. Well, and then present your supporting evidence why that's untrustworthy.
For the reason I just said, nobody measures apparent things ever.
Well, that's wrong.
I mean, they shouldn't.
I just showed you somebody. The entire field of surveying measures that. So you can't say nobody.
Yeah, what I meant by that is I was trying to be, very friendly by saying that they shouldn't. It's a complete nonsense when you are measuring an apparent thing. You can maybe calculate it, maybe, to get a good theory and thesis behind it. But not measuring, that's not measurement.
Says you, in disagreement with the entire field of surveying. So is your personal opinion somehow more valid than the entire field of surveying? Because so far, all you've given is your personal opinion. It's your personal opinion.
The appeal to authority, that's what it's called that you're doing right now. But
you are saying that your personal opinion is all that matters in comparison to other people that are actually, that do this particular thing.
That has nothing to do with the debate itself.
Okay, so your opinion has nothing to do with it.
He's measuring.
Do you have any
it doesn't.
evidence for that then?
what evidence for not you shouldn't measure apparent things, because you cannot, because it's apparent.
Go ahead, present your evidence that is an invalid way to measure things.
Invalid way to add that. I wasn't talking about invalid way for measuring things. I was talking about this observation that you brought up, and I'm saying that it's not a measurement for an observation regarding a physical thing, because it's apparent, and you admitted that.
Yes, and there's no problem with that, because the conflating variables have been addressed.
Have been addressed.
Yes.
I'm not sure, but I think I didn't see refraction even written on the page.
No, like I said,
I might be wrong.
And I addressed the effects of refraction by citing many measurements of refraction. So I presented measurements. You said, what about refraction? I presented measurements of refraction and how it will affect things and how it will cause the apparent elevation of the distant object to be higher than it actually is. Therefore, there is more drop than reported. And you still say, nuh-uh. Well, I don't really care about your incredulity. If that measurement is invalid, or if refraction points things or causes things to appear different than the measurements I have cited, then go ahead and bring your evidence to that.
Again, did you bring your evidence after I just explained to you why you shouldn't ask for it from me, at least?
That's just your opinion. Like I said, it's just your opinion. So do you have anything other than your opinion on this?
No, it's basic logic. We are measuring physical things, not apparent things.
Yeah, and like I said, the errors due to that have been accounted for.
You just said that you counted it for, not justly. So I don't even get what you're saying right now.
Yeah. Thing is, it doesn't help you. But, but you're right. I accounted for it. I showed that the effects of refraction will increase the actual curve, not decrease, not flatten it. So you claim that sea level is flat. I'm showing you that this isn't the sea, this is a lake, but it's water. So I'm showing you that water is curved over a large distance. Do you have anything to the contrary? Because your claim is that water is flat. Right?
Yeah, if you phrase it that way, I do have something.
All right, excellent. And I'd love to see the measurements of the flatness of water. I hope that they're more a higher quality, and certainly you will never allow any measurements that are affected by refraction. But please bring them.
Again, my claim starts that measurements should be done on physical things.
Excellent. Yeah, just present it. Go ahead. I'm ready.
Not on apparent things.
Okay. I'll just let you.
That's the basic logic that I was trying to push through, but it seemed like I cannot for some reason. That we do not measure apparent things.
Yeah,
ever.
Good. So show your measurements of non-apparentness of the flatness of water. Go ahead.
Over a long distance, and that's what I also talked about.
Yeah, go ahead.
Over a long distance, like over 100 meters, you cannot measure any kind of deviation from a horizontal plane, because if you do, then you're just claiming that, it seems like it's below something. Because that's what an apparent thing means, right? It seems like this or that.
Look, you keep going in circles here. You have claimed that water is flat. You have also claimed that you cannot use apparent measurements of it. You've also claimed that you have evidence of water being flat. So I just go ahead, present that. I'll stop talking and let you present your measurements that are non-apparent of the flatness of water.
Again, I do not have that. Okay. I already told you. I do not have that.
Were you unaware that we were going to have this happen today? We talked about it.
No, back to or MC2. I'm not sure. Which one do you like more? Mactoon or MC2? Whatever.
Yeah.
Okay, so MC2 because you are kind of an MC in a certain way. So I do not have that. Okay. You can talk about it again and again, but it's not gonna help you in the debate itself because I let you talk about very something different for the past like 30 minutes, right? That we actually agreed upon for the length of this debate altogether.
All right, well, let me just read part of our conversation. I said, so you get measurements of mean sea level is not curving anywhere or something similar. And you agreed to that.
Okay, that's it. I already addressed it, didn't I?
No, you never brought measurements of mean sea level not curving anywhere.
I didn't even address it. The measurements of over long distances that it literally cannot be done.
So how could you suggest that water is flat if you don't have any measurements of it? Is it just a religious belief?
No, that's not what I'm talking about. What I'm talking about is that the question itself is incorrect.
Okay, well then what's the right question? I know the answer is 42, but the question is still pending.
How would you rule out apparent things over long distance? That would be the question.
I covered that already. You would take previous measurements of these things and include them.
You actually said that you accounted for refraction. Jesse didn't, and you say that refraction is gonna bend light always downwards,
yes.
right?
Yes.
No other way.
Well, not. I'll qualify. Not always. There are corner cases where it does bend the other direction, but they're extreme, and you can see through the environmental conditions what's happening. For example, you'll see lots of layering of other things happening in the atmosphere, especially near the horizon. So you'll see miraging, both inferior and superior, as well as wavy things that are straight getting distorted. So, but that isn't happening in this particular case.
Well, how would you know that if it's just a picture, by the way? And second of all, it still could happen. Like the mirroring effect could be looking like that.
Certainly could, except
you cannot determine that just by.
He wasn't measuring it near the horizon.
No, he wasn't there.
Yeah, and so if there was mirroring happening, you would see mirroring happening, which we did not see. The mirroring happens very near the horizon, and he intentionally got his instruments away from the horizon so that he could avoid those types of effects.
What I meant is that he was only measuring an angle in between apparent things.
Yes.
Well, one being the arbitrary horizontal plane, which is not even there, right? So,
well, it's not arbitrary. It's 90 degrees from zenith.
There is no literal plane there. That's why it's arbitrary.
Okay.
Or is it a physical one? You think
it's not a physical plane.
OSP or something like that, and
it is a
established
a conceptual plane. Yes, exactly.
Yeah.
So I'm still kind of baffled. You were going to bring measurements of mean sea level not curving, and so far you haven't. Did you forget the conversation we had?
Yeah, because it cannot be done. Like, I don't know how many times I have to say the same thing again.
So then why would you make the claim? Why would you make the claim that sea level is flat if you admit that it cannot be measured? That sounds like a religion to me.
Now, for example, by the way, because of the sea level is used for what? Establishing a plane from which we measure elevation.
Sea level is not establishing a plane. Sea level is a curved surface. Again,
that's not what I said.
No, you said you claimed that sea level is
every
a plane.
continent.
Yes.
There is a benchmark for every continent.
Yes.
It's called a benchmark. It's a point that is made by consensus to be a point from which they measure elevation.
Yes.
Now that point actually is a horizontal plane from which
actually is not.
They have a distance. It's an arbitrary plane, of course, but that's a reference point.
It's a measured curve.
Zero elevation.
Yeah, elevation is relative to a vertical datum. A common vertical datum is NAD 83. Another one that is both vertical and horizontal is WGS 84. Both of those are ellipsoids. They are not planes. There's older ones, NAD 26, I believe, and then they even some countries still use the Bessel curves from the Bessel survey from the 1800s, I believe.
So they are actually using different kind of model planes. Model.
It's not a plane. Don't say plane. It is an ellipsoid. The Bessel ellipsoid of 1841 is one of the earlier ones that many countries use as their vertical datum.
So what I wanted to ask is, they are using different kind of models for their zero elevation.
Yes.
Establishment, right?
Yes.
But at the very end of the day, they come up with any kind of shape.
They came up with an ellipsoid
for the Earth. Based on different models.
The model is based on measurements, like the Bessel measurement of 1841. And then they use that for their datum within their country. Now, not many countries use Bessel. The radius. What's that?
They measured the radius. That's what you're referring to by measuring the benchmark.
Bessel did, in fact, measure the radius. He measured it, this is awesome, at 3,272,077 toises. They used toises as a distant measurement there, which is 6,377 kilometers.
I'm sorry, mean sea level in elevation means zero. So what do you mean by measuring zero?
Well, you asked about the radius. This particular survey that Bessel did in 1841.
The radius is mean sea level, isn't it? In other words,
it's part of it, because mean sea level is an ellipsoid.
Part of it.
And the ellipsoid requires 2 radii. So the other radius is 6,354 kilometers.
From what? I don't get it. We are talking about the radius,
from the center of the Earth.
Okay. From the center of the Earth. So how was it measured again? Because I don't get that part.
He goes over the survey in his publication, published in 1841. Mm-hmm. And I will link.
Can you recap it,
Yeah, I did.
I do not have a problem.
Sure. I will recap it.
If you say a few things wrong.
He measured the polar radius and the equatorial radius of the Earth and published it in his survey. That then defines an ellipsoid.
Mm-hmm. Polar radius and equatorial radius.
Yes.
May I jump in for a second?
Sure.
What did you bring in Watsupp for evidence? Did you bring anything with you at all?
No, I didn't.
Okay. Just wanted to check.
I claimed that 4 times. No. I claimed that 4 times, and I don't know what that got to do with the debate. Structure is for moderation.
Because you had agreed you were going to
now, but okay.
You agreed you were going to bring measurements that mean sea level does not curve.
Yeah, again, it's a nonsense claim in the first place. That's why.
I agree. Claiming that mean sea level doesn't curve is a nonsense claim.
Yeah, sure. So, again, equatorial radius. What did you say? Polar and equatorial radius.
Polar and equatorial radius.
Yeah.
So these are that defines the ellipsoid then? That was an early
I know,
datum.
it's not an end.
What's that?
It's not an end. It's the same thing. Polar, equatorial. Really.
It's not an end.
So there is no end in between those two words, polar and equatorial. So it's not two different things. That's what I was trying to say before you cut it in again, like 5 times. Never mind again. What I wanted to ask again is the measurement of that.
Yeah.
From the center of the Earth. That's what you claimed.
He measured the radius. The two radiuses. Radii.
Which makes up an ellipsoid. Okay, great.
Yes.
I get that, no problem. But how was it actually measured? That's what I asked.
Well, it's being that he is a surveyor, it's done through apparent things with margin of error corrections. So what they do is they measure the distance along a line of longitude and the distance along a line of latitude. They use those to get the circumference of each of those. Right now, once you have a circumference, then you can get the radius.
Mm-hmm. What? I have 2 points far away from here in the distance, and
yes.
I can draw a circle from which I can, of course, I get right there. I get the circumference of the circle. But how does that measures the radius of the Earth?
So once you have a circle, you can use the formula. Just a second. What? Okay. All right. I have to go very soon. Once you have the circumference, you can use a formula. Do you know the formula for that? 2 pi d? 2 pi r. It's pi d or 2 pi r. That so you can a little bit of algebra then, and you can get the radius once you know the circumference. Yeah.
No. So, you said that you had like 2 points that you had on the face of the Earth.
Yes, 2 points on a line of longitude, 2 points on a line of latitude. You measure the distance between them using surveying techniques. Once you get those distances, then you can get the radius, because the distance gives you the circumference. Then, right?
The distance gives you the circumference if you have a supposition about the Earth's shape already.
Yes, but the shape of the Earth has already been established.
Also, So he measured the Earth's radius by having already that. Or what do you mean?
He measured the radius of the Earth. Yeah.
Yeah. He measured the radius of the Earth by having that in the first place.
No. He didn't first have the radius of the Earth.
You just said that, sir.
People had previously established that the Earth is a sphere. So this all came from your misunderstanding of mean sea level and your fraudulent claim that mean sea level is a plane. And then I gave you that Bessel is one of the early ellipsoids that were used to establish mean sea level, which are ellipsoids, not planes. That's all the point is, right? So the problem is, you have established absolutely nothing. You've brought zero evidence to this. You said you were going to bring evidence. All you have is incredulity, and I don't think that optical measurements can be used. Yet you still claim that mean sea level is flat without any evidence at all. That is an absolute religious claim. You brought nothing for evidence, even though you said you were going to. This makes me quite upset. So I need to go. You lost. You brought nothing. Ranty and Amy, anything you got?
By the way,
I do want to say thank you very much for coming.
Yes, thank you. I will have this hopefully later today. Thanks for coming. Awesome. What's up? I'm glad that you brought absolutely nothing. It makes it funny.
Yeah, sure, buddy. No problem there. I hope you get out something from this.
I did. Yep. You have a religious faith that the Earth is flat. It's a religion for science deniers.
Sure, no problem there. I have simple questions, and the last one is the best one. Thank you.
Yeah, thank you guys for both coming. Really appreciate the civil nature of the debate actually as well. It was nice to actually hear both of you. Yeah, very well done, you guys.
All right, thank you.
Thank you.
Thank you so much.
Have a good time.
All right, bye. Well, there it is. Watsupp debating me on the shape of the Earth and bringing, to nobody's surprise, absolutely zero evidence. He seemed offended when I asked him for evidence, even though he agreed he was going to show evidence. How strange. But anyway, thank you very much for Watsupp for, I guess, the refreshing just admitting that you don't have any evidence. So it's not like we didn't know. Anyway, I hope you followed along with your bingo sheet. I really only got 3. I got incredulity, which is his main thing. I don't believe it. Dismissing evidence outright and claims without evidence. There it is. Thank you very much. We'll see you next time.